Okay, well, it should be clear, and you should have noticed when you looked at the dice at the beginning, in the beginning of the last clip, that two dice actually cover a little more than an inch. And of course we saw that toward the end of the clip also, if you were able to see the ruler, the meter stick, in good detail. Now, what it looks like to me, ballpark, pretty close, it looks like two dice cover about 1 1/4 inch, not just 1 inch. Okay? How does that affect our result? And we have the result for the case where you have half-inch dice. Two dice to an inch, so the two dice cover an inch. And I don't really have to take all that away. You know, that's what we did here. So if we multiply 8 by each of these numbers, that would be each of the class's estimates based on this assumption. But now we have to modify that, because two dice cover more than an inch. Well, think about this. Pause and get it straight in your head before you hear me say it. Everybody in class pretty much got it, but you know, if you're watching this in video, especially if you weren't in class, you want to stop and think about it. The question being, okay, if two dice cover 1 1/4 inch instead of an inch, is the result going to be more or less than what we get when we multiply 8 by this number? In other words, you're going to have more dice or fewer than you would have if they were half-inch dice. Well, everybody said, well, you're not going to have as many because the dice are bigger, so it's going to take fewer of them. That's absolutely correct. Now, so one way you could answer how this will affect the result is it's going to make the result less than it was. Okay? But we want to be more specific than that. You've got specific information here. Can we get a specific estimate? Well, hit. The length, width, and height of each die is 25% greater than we were thinking, isn't it? Because 1 1/4 is 25% more than 1. Okay? A quarter is 25%. A quarter of 1 is 25% of 1. So if we add a quarter to the 1 inch, we've increased it by 25%, haven't we? Make sure you understand that. Okay. So the length, width, and height of each die is 25% greater than we were thinking if we had thought that there were two dice per inch. And that was a fairly common assumption. It's not a bad assumption. It's a good ballpark assumption to base a refined estimate on. So, the question now is, how much greater is the volume of the die? Okay? If each die is 25% longer, 25% wider, 25% higher, then how does its volume compare? Well, you might say, well, it's 25% more. Well, that doesn't work. And think back to what we thought about earlier when we said that some people might want to say, well, if there are two dice per inch, you just double this number. Why didn't we just double it? Because to make a 1 inch cube, we'd have to have 2 rows of 2 dice to make 1 layer, and we'd have to have 2 layers. Okay. Of course, I built that for you right here. So, you know, you might look back to that if you're not sure of it. And the result was then that there were 2 times 2 times 2, or 2 cubed, or 8 half-inch dice in a 1 inch cube. There would be 8 half-inch dice in a 1 inch cube. Okay. So you ought to think about that before you look at anything else, before you look at what I've written down here or anything. Well, hopefully you've thought about it, and the result is going to be, by analogy with this, we would think, well, okay, if we want to use 1.25, because people seem to be more comfortable with decimals than with fractions, okay, so your dice are 1.25 times longer, 1.25 times wider, and 1.25 times higher than they were before. You would think, by analogy with this, that you would have 1.25 times 1.25 times 1.25 times the volume, wouldn't you? So you could do that, okay? Now it's really easier if you don't use a calculator, and you really shouldn't for this calculation, to use the fraction 5/4. Okay, 1 1/4 is 5/4, so each of these is 5/4. This is 5/4 as big as this. And you really need to understand fractions that well, if that isn't completely obvious to you. In any case, instead of doing 1.25 times 1.25 times 1.25, we could do 5/4 times 5/4 times 5/4. And that would be 5 times 5 times 5 divided by 4 times 4 times 4. Well, you really ought to be able to calculate 5 times 5 times 5 in your head, and 4 times 4 times 4 without too much trouble. You get 125 and 64. So, if the length, width, and height are all 5/4 as much, the volume will then be 5/4 times 5/4 times 5/4, which is 125/64 as big. Okay, 125/64 the volume. Now 125/64, it should be pretty clear to you, is pretty close to 2. Why is that? Because 2 times 64, which is really easy to calculate, is 128. And that's 125. If that was 128 over 64, it would be exactly 2. 125 is really close. So we say that that's close to 2 times as great. Now there were a couple of smudges there, so actually need a longer piece of chalk, but I don't know where it is. I'll try. Close to. Now that 4 there, it looks like it's saying close to 4, but that 4 is part of the 5/4. Close to 2 times as great. Okay, so turns out then it only takes half as many dice as it would if they were half-inch dice, provided the dice are 1 1/4 inch. It takes half as many 1 1/4 inch dice to make a 1-inch cube as it does half-inch dice, approximately. This isn't 2, it's like 1.95, but it's close to 2. So for a ballpark figure, you can say, okay, well, then instead of taking 8 half-inch dice, we do half that many, or 4 1 1/4 inch dice, and that should be a 1-inch cube. Okay. And they're not 1 1/4 inch dice. It's 2 dice cover 1 1/4 inch, so it's 2 to 1 1/4, and I've been saying it as if it's 1 1/4. Still, hopefully the idea comes through. And I'll do a quick video correcting my terminology there.